Will be flying the C-7A Caribou in remote, underdeveloped areas of the world. Short, primitive runways hacked from the jungle and desolate terrain make these parts of the world caribou country. With a short field landing capability, it often is the only timely means of delivering much-needed supplies and men to forward areas. The entire trailing edge of the wing, which functions as a movable flap surface, permits a safe threshold speed of 67 knots at a gross weight of 28,500 pounds and flaps set at 40 degrees. Utilizing brakes and full reverse power, the aircraft can come to a dead stop within 525 feet after touchdown. At a gross weight of 26,000 pounds, it can lift off within 650 feet from even the most makeshift runway. If a landing strip is unavailable, men and supplies can still be delivered to remote areas by airdrops or by low-altitude extractions. This film will introduce you to C-7A delivery techniques and procedures and show you how they fit into tactical airlift operations. As a C-7A crew member, your mission will be to fly men, equipment, and supplies into short, primitive runways. This demands special landing and takeoff procedures. In this case, we'll fly a standard short-field landing pattern. Prepare for your final approach by keeping the downwind leg close to avoid ground fire and initiate the before landing checklist. Pull the power back to 18 to 20 inches of manifold pressure. When opposite the touchdown point, lower the landing gear. As the airspeed decreases below 105 knots, the co-pilot sets the flaps to 15 degrees at the direction of the pilot. Airspeed is reduced and maintained at 85 knots on base leg. Nearing the final approach course, the pilot calls for 30 or 40 degree flaps and turns to final. On this approach, the pilot calls for 40 degrees. Now complete the before landing checklist. The prop lever should be moved to full increase RPM position. The hydraulic pressure is checked normal and the gear is rechecked down. On final approach, slow the aircraft to the short field threshold speed. This speed is normally established at a point 1/4 mile from the end of the runway. Use pitch control to maintain airspeed, adjusting throttles as required to maintain the glide path. A 400 to 700 feet per minute rate of descent should be flown, and the touchdown should be from 100 to 200 feet from the end of the runway markings. On this approach, the pilot aims for the touchdown area on a landing zone outlined by marking panels. Just before touchdown, slowly close the throttles to idle and apply a smooth, continuous back pressure to the yoke. Don't be surprised if you feel the light stick shaker. As the main gear touches down, move throttles into reverse thrust range. and apply intermittent braking to stop the aircraft. Before dust and debris are blown forward of the engines, bring the throttles out of reverse range. A variable pattern entry can be any type except a standard approach, and is designed to place you outside hostile ground fire or friendly artillery range. Here is an overhead approach. Enemy ground fire on one side, friendly artillery on the other. Deny a normal traffic pattern. Initiate the descent and before landing checks before reaching the approach end of the runway. Over the touchdown point, maintain an altitude of 1,500 feet or higher, depending on the circumstances, and airspeed of 110 to 120 knots. Now bank approximately 30 degrees right or left, and retard power as required. After turning 180 degrees, roll wings level to lower landing gear and set flaps for landing. Continue turn toward the runway, adjusting power to maintain a safe airspeed for the flap settings. Either a short field or normal landing may be executed. Here is another example, the modified straight-in approach. Because of the tactical situation on the ground, a 360-degree approach is inadvisable. Enemy and friendly forces may border the airfield on three sides. A modified straight-in approach is the only way in. Terrain, weather, and the combat situation will dictate the altitude and exact heading to the field. Select gear and flaps a sufficient distance from the field to ensure a safe approach and landing. You have seen two, but there are many other types of variable pattern entries. A variable pattern entry under certain conditions will enhance the chances of a successful mission and survival of crew and aircraft. On a short field takeoff, accomplish the before takeoff check. The flaps are set to 25 degrees. Center the nose wheel and hold the brakes while accomplishing the line-up checklist. When the checklist is completed, prepare for takeoff. Advance the throttles to max power. Check and stabilize the engine instruments. On a slippery or sandy runway, it is best to release the brakes before obtaining max power to minimize danger of equipment damage from blowing sand or gravel or skidding of the aircraft. Maintain directional control by nose wheel steering and differential power if necessary. Steering can be assured if the co-pilot holds the control column slightly forward of neutral. Keep the wings level with the ailerons. When rudder control becomes fully effective, but never below 55 knots, discontinue nose wheel steering and transition to the yoke, moving it aft of neutral. Then rotate the aircraft to make sure the nose gear lifts off before the main gear. Liftoff speed is 55 to 64 knots, depending on the gross takeoff weight. When at a safe altitude, retract gear and flaps simultaneously. Don't rotate the aircraft to an angle that will cause a drop in airspeed and result in stall. If necessary, fly 360-degree spirals to a safe altitude above ground fire. If no airstrip exists, or it is under enemy fire, a personnel drop may be the only way to reinforce a Special Forces camp. A briefing by the aircraft commander precedes the mission. He reports the altitude they will fly to the drop area, the weather they will encounter, in-flight and emergency procedures to observe. Inside, the flight engineer has prepared the aircraft for the paradrop. He has checked the anchor line for security. He makes sure the static line retriever is operational. Now the aircraft is ready for the troopers. Flying to the drop zone, the aircrew, pilot, co-pilot, and flight engineer conduct a series of checks. The first check takes only a moment.
Co-pilot engineer, this is a 20-minute warning.
20-minute warning acknowledged. Twenty-minute warning complete.
Next, the 10-minute warning check. After the co-pilot transmits the warning to the crew, the flight engineer notifies the jump master. The pilot and co-pilot review the final checkpoints to the drop zone and the altitude at the release point. As the aircraft approaches closer to the release point, the co-pilot transmits the 6-minute warning to the flight engineer and activates the red caution light.
6-minute warning acknowledged. 6 minutes. 6 minutes. 6 minutes.
After notifying the jump master, the flight engineer activates the cargo door and ramp switches. From now on, activity will be continuous until the signal to jump is given. In the cockpit, the co-pilot receives last-minute instructions from the combat control team on the ground. The controllers give conditions on the drop zone, such as wind velocity and direction, also any condition that could affect the jump. The pilot now takes the aircraft to drop altitude while reducing airspeed to 110 knots, the normal drop speed. In the cargo compartment, the flight engineer ensures the cargo ramp is set at 15 degrees below horizontal. Troopers hook static lines to the anchor line cables.
Hook up! Start your equipment check.
Following the buddy system, they check each other's lines, parachutes, and drop equipment. As an additional safety measure, the flight engineer double-checks the drop equipment. And the jump master, who is one of the jump team, double-checks the equipment of the troopers. 1 minute away from the release point, the co-pilot transmits the 1-minute warning.
Co-pilot engineer, 1-minute warning.
The pilot stabilizes the airspeed at 110 knots and establishes the drop altitude. On the ground, the combat control team radios the final heading to the aircraft to assure proper positioning over the drop zone and calls the release point. The co-pilot hits the green light switch, and it's go. One second prior to expiration of the usable DZ length, the co-pilot activates the red caution light. The flight engineer retrieves the static lines and closes the cargo ramp, and the pilot regains normal speed and altitude for the trip home. An alternate delivery method when air-land operations are not suitable and a landing strip is not available is the gravity airdrop. The flight engineer who helps load the aircraft is responsible for the cargo from tie-down to release. He must see that the cargo is secure and check the drop equipment, the manual release device, the static line, the center anchor line cable, and associated safety chains and tie-down straps. Following a briefing by the operations officer, the crew and aircraft take off. En route to the drop zone, the 20 and 10-minute warning checks are performed. The pilot and co-pilot review the final checkpoints en route to the drop zone, the altitude and airspeed for the execution of the drop. Then comes the 6-minute check, which is completed at least 1,500 feet above ground level.
Co-pilot to engineer. This is a 6-minute warning.
The co-pilot transmits the 6-minute warning and turns on the red caution light. The flight engineer acknowledges the 6-minute warning and checks the red caution light is on. He then starts to prepare the load for the drop. He removes straps and tie-downs. Meanwhile, ground personnel who are awaiting the drop report drop zone conditions. If a combat control team is not on the ground, the pilots determine the release point. Now he plans his approach to arrive at the release point at 110 knots. Drop altitude, depending on the type of parachute used, will vary from 300 to 500 feet above ground level. With all the tie-downs and straps removed, and with the cargo door open and ramp in the horizontal position, the flight engineer notifies the pilot that the 6-minute check is complete. If hostile ground fire is a problem, fly a variable pattern entry to the drop zone. And to lose altitude, fly one or more 360-degree descending spirals until the proper altitude is reached. One minute from release, the co-pilot transmits the 1-minute warning.
Co-pilot to engineer. 1-minute warning.
The pilot selects the booster pumps to normal by activating the 2 booster pump switches. The co-pilot prepares the engines for the power increase required at the release point. He moves the mixture levers to auto rich and positions the propellers at 2550 RPM. In the cargo compartment, the flight engineer removes the load release device safety pin. 1 second after the nose of the aircraft passes over the impact point, the pilot gives the drop command, green light. In the cockpit, the pilot applies METO power and establishes a 95-knot climb. The flight engineer actuates the load release device lever. One second prior to expiration of usable DZ length, the co-pilot turns on the red light. The flight engineer retrieves the static line and closes the ramp and cargo doors. The pilot regains altitude and airspeed for the flight home. Now, the final delivery method. Low-altitude parachute extraction, abbreviated LAPES, is a self-contained delivery system that needs no ground equipment. The flight engineer, as in gravity airdrops, is responsible for the cargo from loading to extraction. On such a mission, he's assisted by another crew member. With the load tied down, the parachute which will extract the load at the delivery point is loaded in the ejector rack. A safety line to prevent inadvertent extraction is connected to the extraction chute and to the side of the fuselage. On the way to the extraction point, the crew performs the usual 20 and 10-minute warning checks. Then the 6-minute warning is transmitted by the co-pilot and acknowledged by the flight engineer. In the cockpit, the co-pilot starts the before-landing checklist. He selects carburetor air, ram and cold. moves the mixture levers to auto-rich, and increases props to 2250 RPM, preparing the aircraft for the go-around after the load has been delivered. In the rear, the flight engineer sees that the load restraints are removed and safety chains are hooked to the load. The cargo ramp and door switches are activated from the cockpit. And when both are open, the ramp is checked for horizontal position. Meantime, the pilot flies a normal traffic pattern. When opposite the extraction point, the landing gear is lowered and the flight engineer is notified to perform the 1-minute warning check. After setting the flaps at 7 degrees, the co-pilot positions the props to full increase RPM, checks the hydraulic pressure, and the landing gear down. The safety chains and load release device safety pin are removed, and the safety line is untied and pulled free of the extraction chute. Then the flight engineer reports the 1-minute check is complete and the load is hot. After a normal base leg, the pilot makes his turn to the final approach. Just before reaching the release panel, the pilot levels the aircraft at 3 to 6 feet above the ground at 95 knots until extraction. Abeam the release panel, the co-pilot gives the green light signal and activates the pendulum ejector switch. The manual release handle is pulled and the load release device is actuated. After the load clears the aircraft and the red light is turned on, the flight engineer calls load clear. The pilot now applies max power and executes a normal go-around as he heads for home. In your next assignment, you will be putting into practice the procedures you soon will learn in this school. Remember, success depends upon team effort between the pilots and the flight engineer. As a team, follow the rules and employ the correct procedures. Stress safety. Do this, and you will be able to operate the C-7A in and out of short runways and deliver personnel and equipment in the most hostile environment.